Hi everyone. Today we are going to discuss the seventh chapter, that is nothing but a classification of elements, the periodic table. So before going enter into the lesson, we have to know the meaning of the lesson. Means by knowing the meaning, we can gain what is inside the particular chapter and what are the topic that we are going to know. Means according to my knowledge, the things which you are going to know is combined or it will be present in the name itself. Means by knowing the name of the chapter, means the meaning of the name of the chapter, we can get some idea. Yes, that is the thing that we are going to discuss in the particular chapters. So when we are going to know about this classification of elements, first of all, already we in the last chapters and the last classes that we had already have a knowledge about the elements. It is a thing basic thing of a particular substance. Here and up to now we have know the 30 elements of the periodic table. So each and everyone has to get the information, minimum information about 30 elements, which are very important to classify or to know or to make the properties and to know that different things about the elements. Those are nothing but hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. So these are the 30 elements that everybody has to know. So here the elements, that all the things, that all the history of the element, atom, molecule, that already we discussed in the chapter 6. Now we are going to know has the chemistry as a not only chemistry, the science, it is the one, it is continuously, it is changing one. Means today science may be tomorrow science or not. We are not sure that every day the same science will exist, because in previous days they thought that sun is not a center of that universe, it is center of universe. But afterward they comes to know it is also one of the planet that is going to revolve around the sun, like that. So on that day it is the center of universe, that is a science. But now sun is the center of universe, it is the planet that is revolving around the sun, that is the science. So science is a continuously changing. The same way in chemistry also we can have different types of things. So here when we go with that topic, so what is the need for classification of elements? Means up to that particular time, by the time of things, as we can say that is exactly by 1661 or 1660 time, more than I think 63 elements had been discovered. But the scientists now, but the first thing is, first of all they have to know what is the basic. After getting know what is the basic, they has to know what are the names of that one. After getting the names, they has to know what they have to call as in universally. And after getting know, it means every day we will get a different types of things. As we are human beings, we won't stop at the point that we already know a particular thing. So we will try to explore and explore and explore. So after knowing the elements, now the biggest topic is nothing but how can we classify the elements. So before knowing or before getting into the topic of how, we have to know why. First of all, why we have to classify the elements, means what is the need for the classification of elements. Is there in need of classification? Classification is nothing but we are going to divide. Means here when we are going to divide, again we will get different types of doubts. What are the doubts? Means how can we divide? Means based on which thing, means based on which one we have to divide. For example, if you go with a supermarket or a medical shop, if we, I think the perfect example is supermarket. So when we enter a supermarket, we can see all that groceries at one side, all that soaps at one side, all that different types of eatables at one side. Means each and everything has been characterized or has been divided based on the things or based on the uses, based on their uses, simply we can see. Means by that we can say these are all our soaps, these are all our detergents, these are all our food items. So that is a easy method that we can pick up which one we want. Here also, by having the classification in the between the elements, we can say the properties, or we can explore about more about the elements. So there are different types of scientists, they tried and tried and tried and tried. So in that one, so many had failed, but some of the persons they had achieved, and they had contributed more to that chemistry. So they had been in that one. We are going to know only some of that experiments and some of the things based on the classification. In the button, the Robert Boyle, he had started at initialization state, and he had make them into he had tried into making them into groups and everything, but at a particular stage he had just had when stop it. And then afterwards the Daubernier, so he is the first man who had tried, means who had tried, means before also there are more number of a person they had tried, but famously the Daubernier is one of the German chemist. His full name is Johann Wolfgang Daubernier. He is birth year is 1829. He is one of the scientists who had tried to classify the elements in the form of triads. Triads. Tri means a three. Means in the form of three elements. Okay. So he made a group of three element. Okay, three elements as a group. How he had made a based on increasing order of their atomic weights. Okay, so based on that he made three elements as groups, and he classified the particular things. How he had classified: the average weight of first and third element equals to, okay, the average weight of first and third element equals to the weight of the middle element. So which elements will satisfy, okay, now which group will satisfy those property, then he can say that these three are one group, these three are one group. Like that he tried to classify the up to the elements which on by which time he by the time. Okay, so here these are the things that means he tried. And but at that time there is no classification. Before Daubernier there is no classification, that is the first classification, so everybody they accept it. And every but after means suppose as we know something, we will do an experiments, right? So when we are going to do experiments, at the time some of that elements are going to pass in this one, but some of the elements they are not going to satisfy. So there are so many disadvantages and there are so many limitations. But the first limitation is making the particular group of elements as triads is one of that disadvantage. And sometimes he made a very low mass elements and a very highly mass elements as one group. That is one of the thing, especially in uh, when we compare, when we're going with this elements like fluorine and bromine, in those cases also we can see. And the main drawback we can say this, he had taken atomic weights, because atomic weights will be differ for different types of elements, right? There is no rule that every atom will have the same atomic weight. So by that one, his atomic that is not the atomic classification, the classification of elements theory has been failed. And next one after that, the another scientist who is is a British chemist. His name is John Newlands. He came in 1865. He just forwarded. He had submitted, or he just proposed one of the classification. So previously Taubenier he just classified elements as a triads three. Now he tried to classify it in the form of eight. So in the form of eight means actually before the classification only he had taken an example. How he taken an example, I think those persons who knows music, they know we have different types of tunes: sa, re, ga, ma, pa, da, ni. So there is no eighth tune. Again the sa which is present at first, it will repeat again. The same way he said that he arranged the elements, okay, now in the increasing order of the atomic weights. Again atomic weights only he arranged, and he said that again eighth element will resembles the properties of the first element again. Okay, like that he proposed, and he classified the elements in the form of 888. So every first element and eighth element will resembles same properties, means same atomic in the same type of characteristics. Is it clear? So here when we are going to know about all these things, he means first of all, Robin here, he just means he is the one who had classified in the terms of three elements. And now means some more improvement we can see in the Newlands law of actives. Here he just classified, he also classified in the terms of atomic weights only, but he classified in the terms of eight elements, means there we can see some more improvement, but these are also failure. So why it is failure? Because it is not applicable to all the elements, means what are the elements that had been discovered up to so far, it is not at all going to resemble, and it is not the one, and he can say, he cannot say why that eighth element which should be resemble the properties of the first element again. So these are some of the things that one. So after all these things again, so many researchers had been done. So classification, at least they had got some idea. Now how can we keep, how after classification, means how can we propose to the outside world, by the means how can you propose to the outside world, how this is a classification, these are the things, this is one group, this is a one, these are all set 1, these are all set 2. So that is known as a periodic table. Periodic table is a one by which we can say the elements belongs to different categories, means we can categorize by using only periodic table. In that one, Mendeleev is the first person who proposed the first periodic table. Before Taubenier and Newlands, they just classified, but Mendeleev is the person who just proposed the first periodic table. So is a one Mendeleev, he arranged, he also used this atomic weights only. So here when we are going for the concept of important questions, we can have the proper, means when we are going to write about periodic tables, first of all you have to write periodic law. So by using law is nothing but based on that, only based on that principle he is going to classify the elements. So what is the law? What is it law? The physical and chemical properties of the elements are periodic functions of their atomic weights. The physical and chemical properties of the elements are periodic functions of their atomic weights. Means based on weights, means physical and chemical properties. Okay, now means physically atomic weights, physically if we see atomic weight, we should be taken as a property. Chemical also we can say, chemical also we can take atomic weight as also property. That is the reason, and that is the main one that we has to remember when we are going with a Mendeleev periodic table. So there are some, when we are going to know about this one, we have some silent features. First of all, he had made the particular periodic table into groups and subgroups. When we go with the particular groups and subgroups, there are 8 vertical columns in Mendeleev periodic table called as groups. Means all the vertical columns are groups and horizontal rows are called as periods. Okay, so first of all you are going to know as groups and subgroups. He had groups of 1 to 8 and they had been represented Roman numerals, and again each group is subdivided into A and B, means 1A, 1B, 2A, 2B, like that. 8 groups and 8 groups are divided into subgroups, means totally 16. And then he had classified the horizontal rows as columns, and he mainly classified the rows as 7 rows, means 7 periods, means 8 groups and 7 periods. And the main thing that he had succeeded, it is nothing but, so he knows previous only, means at the time all I think 63. So now at present we had more than 118 elements had been discovered, but when the Mendeleev is going to propose maybe 60 to 70 types of elements, so in his periodic table he left the spaces between the elements, means as he proposed the particular periodic table based on atomic weights only, but he predicted there may be some elements that they will be in this particular place, and he left the places, means he predicted, means at that particular place the property of the element also he already predicted means he just thought yes that may be. So in that one we have different things. For example, we have that and for those elements he kept the prefix as eka. Okay, so for example, for those elements as eka boron, eka aluminum and eka silicon. Okay, eka boron, eka aluminum and eka silicon. So after it had been proved correct, how, means after so many years they had discovered those elements, right? So it's exactly same scandium, gallium and germanium had got the same properties, like Eka boron means scandium, eka aluminium as gallium, and eka silicon as germanium. Okay, and the fourth highlight of this periodic table is he corrected atomic weights. So before that, there may be some predictions that this is atomic weight, but by you he is going to express his atomic periodic table, he just corrected the wrong atomic weights and he had corrected atomic weights. So he used a principle as atomic weight equals to equivalent weight into valency. By using this principle, an anomalous series, the fifth, the very important silent feature of Mendeleev periodic table is anomalous series. What do you mean by anomalous series? What do you mean by anomalous series? Anomalous series is nothing but as whenever he is going to arrange, the element which is having lesser weight should be back and the element which is having more weight should be after. Means it should be in ascending order, not in descending order. So he is the first one who introduced anomalous series in the classification. Whenever he is going to classify the particular elements, it is a principle that he used. So as he proposed the first periodic table and everything is success and no issues with that, but there is some issue, there are some limitations also in that one. The first, this one is anomalous pair of elements only, means he just not placed high. C is the person who introduced anomalous series, but he failed. For example, we can say tellurium and iodine. As tellurium is having 127, he kept first, and iodine is having 126, he kept next. But according to anomalous series, low should be first and high should be next, but he displaced. And second one is dissimilar elements placed together. So as we already know that it had been divided into groups and periods. In groups it should have contain same properties, right? But sometime in some places he placed similar type properties of elements had been placed in one group and similar properties placed in the periods like that. These are the disadvantage that we can say about Mendeleev periodic table. Now the next topic is about the modern periodic table. Modern periodic table is nothing but the next version. Means previously up to now we just use the topic of we just use the concept of atomic weights itself. Now we are going to enter into atomic numbers. So this modern periodic table had been introduced by H.J. Moseley 1913. The year 1913, H.J. Moseley, he is the one who introduced the modern periodic table. So the periodic law of the modern periodic table is the physical and chemical properties of the elements are periodic functions of their atomic numbers or electronic configuration. The physical and chemical properties of the elements are periodic functions of their atomic numbers or electronic configuration. So here I used the word of periodic numbers or electronic configuration. Means as electronic configuration is nothing but the number of electrons that is present only. By that only we are going to write right. So by using atomic numbers are nothing but it's also same concept. So here we can say that the physical and chemical properties of the elements are periodic functions of their atomic numbers or electronic configuration. So by using that principle he just classified. Is it clear? Now we are moving to what are the things that are going to be here in this one. So he also placed a different also classified based on the things into periods and groups, and he named groups, that means vertical as groups and horizontal as column, horizontal as periods. And he named different types of blocks also, S block, P block, T block and F block elements. Means how can we make based on the valence electrons. Suppose all the S, means suppose if the valence shell is going to have all the S1, then all that will be in a particular block, and P and D and F. So all the S block elements will be in a particular place, all the P block elements in a particular place, all the D block elements will be a particular place, and all the F block elements will be particular place. So when we observe this periodic table, we can see the all that under the periodic table we can find two different types of blocks separately. Okay, they are called as lanthanoids and actinoids. So they are from 58 to 71 and 90 to 103. So 58 to 71 are the nothing but lanthanoids, and 80 to 100 are called as actinoids, because all those means all the lanthanoids are having the same property and all the actinoids are having same property, and they are F block elements. When we see the electronic configuration, we can see the final shell contains F block in their electronic configuration. So all the F block elements are called as inner transition elements. All the D block elements are called as transition elements. Okay, all the F block elements are called as inner transition elements. All the D block elements are called as transition elements. And we have 8 groups and 7 periods. So 8 groups, again they had been divided into A and B. In that one we have different types of properties. Based on the properties, again the groups had been divided, and metals and non-metals are also had been divided. So based on the things it had been divided, and how the particular means how that particular atomic radius will be there, and how that we are having different types of properties, right? Means what are the different types of properties we're having: valency, atomic radius, ionization energy, electron affinity, electronegativity, electropositivity, metallic nature, non-metallic nature. So valency is nothing but the outermost orbit, means how many number of electrons present in the outermost orbit, or the combining capacity. So in group it is same for all elements, because it is group is nothing but same properties, no? So all the group elements will have same valency, and in periods it increases from 1 to 4 and decreases to 0. Then atomic radius. Atomic, what do you mean by atomic radius? The distance between the center of atom to the outermost orbit of an atom is called as atomic radius. The distance between center of an atom to means from the nucleus to outermost orbit, that is called as atomic radius. So in groups we can see it is in increasing state, because from top to bottom it is will be increasing, right? And in periods it will be decreasing. And we can say ionization energy. What do you mean by ionization energy? The energy required to remove an electron from the outermost orbit of an atom is called as ionization energy. Okay, means as it is very near to that nucleus, it will be very hard. So as it is very far away from the nucleus, it will be very easy to pick it out, right? So ionization energy will be decreasing in groups, and in periods generally it will increase. And electron affinity. What is electron affinity? The energy released, okay, when we remove an electron. Okay, when we remove an electron, some amount of energy will be released, that is called as electron affinity, and it will be decreasing in groups and increasing in periods. And electropositivity. Electropositivity is nothing but we are going to remove electrons, means whenever there will be removal of electrons, means removal of negativity, that's nothing but it is getting positive. So in groups it is increasing, and in periods it will be decreasing. So exactly opposite to positive is negative, right? So negativity means adding of electrons. In means we are going to add number of electrons. In group it will be decreasing, and periods it will be increasing. And metallic nature will be increasing in groups and decreasing periods. So exactly opposite to metals is non-metal. So non-metallic nature will be decrease in groups and increase in periods. So this are the one that is very easiest chapter, but we have to get more information regarding the elements first of all, then easily we can get knowledge of this particular classification of elements. So by having this classification periodic table, then easily we can get. So please at least please learn the first 30 elements. Those that is must ensure that everyone has to get the knowledge, then easily everyone can gain some at least some knowledge regarding this classification. So the last time I am repeating: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon,